All right, so you watch the video. What do you think? What's your question? What are you asking yourself as you see him speeding down that track? The main question I'm asking myself is how fast is he? How fast is he running? So, the reason we're asking that question today is because our goal today is to look at rate of change, aka slope. And really, a speed is a rate of change. It's how much space you are covering or how much distance you're going in a certain amount of time. So let's make some estimates. What I want you to do, I want you to go and press pause right here and make some estimates with your neighbor. I want you to make some estimates as to what do you think would be way too low as far as speeds, and then way too fast. So that'd be the too high category, and your best guess. All right. So why don't you go and make some guesses? All right. So my guess is gonna be he's definitely going. Um, let's go ahead and say maybe too low would be way too low. Would probably be about 10 miles per hour. I think he's going faster than that for sure. My way too high is he's definitely not going the fastest as a freeway, which would be like um, 70 miles per hour. So my best guess, what do you guys think? Best guess. Hope share some of your best guesses with the class. See what you guys think your best guess is. I'm gonna guess maybe I don't know, maybe 30 miles per hour, something like that. I might be too fast. It might be too slow. Hard to say, right? So we got to figure out some of our given information. And this is where we go back to the video. So if we go back to that video, there are three different speeds or three different times that they give us how many seconds it's taken to get to that point. So I want you to go back to that video if you can and identify those. I'll go ahead and give them to you here though. So what it gave us is it told us that at the 100-meter mark, it gave us a time. At the 200-meter mark, it gave us a time. And then when he crossed the finish line at the 300-meter mark, it also gave us a time. So let's write those in. So at the 100-meter mark, it had taken him about 9.1 seconds to get there. 9.1 seconds. At the 200-meter mark, he had been running for about 19.8 seconds. Okay, 19.8 seconds. And then when he crossed the finish line, he had been running for approximately 31 seconds. Okay, so let's fill those in there. So the question is, can we answer how fast he is? Can we answer how fast he's running? So you've got some space there at the bottom to try and figure this out. So what I want to remind you of is that to answer the question how fast, we have to take our distance divided by our time. We always take the amount of distance we've covered divided by the amount of time it's taken us to get there. So we're going to do that three different times here. Our first time is the 100 divided by 9.1, leave some space. Our second time is the 200 divided by 19.8. And our last one was when he crossed the finish line, 300 meters divided by 31 seconds. So distance divided by time. So some of these we would probably use a calculator for to figure out. I'm just going to go ahead and give them to you. This is going to be approximately 10.9 meters per second. 10.9 meters per second. This one right here, if we divide 200 by 19.8, also around 10.1 meters per second. And then last but not least, if we divide 300 by 31, it's actually around 9.7 meters per second. Okay, so there you go. Let's see. We're actually going to use this last option. Okay, and I'm actually going to show you some quick math here for a second. And this actually goes back to what we learned last unit. 300 meters, okay, every 31 seconds. I want to convert this into, we're not going to do miles per hour, we're going to do kilometers per mile, since we're kilometers per hour since we're in meters. So the way we did this, we taught this to you last unit, was to put meters down here, seconds up here, the meters converted into kilometers, seconds converted into hours. And so now we're left with 1 kilometer is equivalent to 1,000 meters. 1 hour is equivalent to 3,600 seconds. So if we do our math and we cancel everywhere we're supposed to, meters cancels out, seconds cancels out, and we're just going to go ahead and figure out what this would actually be. So I'll help you out. If we multiply all the way across and we convert that into kilometers per hour, it's approximately 34.8 kilometers per hour. Okay, so let's see if we're correct. Let's see if we are almost perfect using our last time here, our last distance in time. So let's go to the next part and you'll see.